Hello. Hello, can you hear me?
Yes, I can hear you.
Okay. So now we will start our today's class. So basically, previous class we also try to discuss about that how we can easily make this type of map, and after this how we can easily make the map layout as well as also all of the legend at the map title using the art map software. We also try to discuss about this part. So mainly today I will try to discuss about that area calculation. So how you can easily calculate the area, and then how can easily calculate the different types of feature, how much urban body, how much water body, how much barren land, how much vegetation are available in this region. We also calculated the area. Okay, so let's go. So mainly we can calculate the area in Google Earth Engine platform for the different way can apply. So I also try to show you all of the way. I hope you can easily understand all of the things. So in this time, first of all, you can see we can applying the chart method. Suppose I also write the comment. Suppose chart, I create a bar column chart for the all of the area calculation. Suppose I create the chart, and this chart represented all of the area in this all of the classes area. Suppose I create the chart bar column for a build up area. I create the bar column for the vegetation. I create the bar column for the barren land. For each area, all of the classes, I create the bar column chart, and then create the calculated the all of the area. Okay, so let's go. First of all, I try to discuss about the chart. I can easily create the chart and also calculate the area for all of the classes. So let's go. So for this, we can easily use the function. Mainly, when you want to use the chart, I can simply use the function UI dot chart.
Please share your screen.
Okay. Sorry for that. Okay. I forget to sharing. Okay, sorry. Okay, sorry. Okay, so now can you see my screen? Yeah.
Yes, now I can see your screen.
Okay. So now I want to make the chart and then try to calculate all of the area. Okay, so I want to make the bar column chart and then try to calculate the area. So in this time, okay. So in this time here you can see I simply first of all I create the chart, and this chart I want to represent it. Suppose bar column, different types of bar column. It represented the different types of feature and different types of class, and it also calculated the area. So I will show you all of the process how you can easily calculate the area. So let's go. So I simply use a function UI chart image, then image by class. In this time, I want to create the chart or bar column chart using the different types of feature or different types of classes, such as vegetation is one class, barren land is one class, urban is the one class. So all of the class I want to create the bar column chart and then calculate the area. So for this I simply use this function, and then I simply get all of the argument. In this time I want to apply make a dictionary. First of all, I simply use it at the curly bracket start as well as also curly bracket end. Okay, then I simply put all of the argument, keyword and key value. So in this time you can see I want to calculate the pixel area. So all of the pixel area I want to calculate it. So mainly Google Earth Engine has a function, this function called the ee dot image dot pixel area. This function we are using for calculating the pixel area in square kilometer, sorry, square meter. This result we can get in square meter. If you want to simply copy this function and paste in the docs tab or documentation tab, simply click here. Here you can see. So mainly this result we can get the pixel result in square meter. Okay, when I want to apply this function ee.image.pixel area, it get the result in square meter. In this time, suppose I want to need the result in hectare or square kilometer. So for this I simply, suppose I need the result in hectare, so just I simply multiply with this value 1 into 10 inverse 4. It is a scientific notation. 1 E inverse 4. Okay. Now I can calculate the area from square meter to hectare unit. Just I multiply with this value 1 into 10 inverse 4. So now in this time, I just simply added here this. You can see this image, this the classified image. Okay, so this classified image is stored in a variable. Okay, so I simply call this variable name. So I simply copy the variable name. You can see this variable name is that. So okay, classified. This variable name is the classified. Okay, so just I simply call this variable name, and then I simply paste here, add bands, and this I simply paste this variable name. Okay, in this time, what happened in this time? Classified image, we can already classified total 4 classes: water, urban, vegetation, and barren land. All of the 4 classes I want to classify. In this time, all of the classes I want to add with this function eimage.pixel area, and it's get the result in square meter. I simply multiply with this 1 inverse 4. Now it convert the result into hectare unit when I want to multiply with this value. In this time, I simply add this my classified image, and now I just simply rename it. Okay, I simply use the rename function for rename this band name. I simply band name, suppose this band name is the classification. You can use any name. I simply use a classification. Okay, now I also need to class band. Okay, so in this time I simply change this band name. You can see classification. So I simply copy the same name and paste here. Okay, then region is your boundary variable name. Boundary variable name, you can see what is the boundary variable name, ROI. Okay, so just I simply use the ROI. Then reducer, in this time I want to calculate the total pixel value, total all of the classes total pixel value I want to calculate. So just I simply use the EE dot reducer dot sum, because I want to calculate the total. Then scale is the resolution of your satellite image, it 30 meter resolution. Then I also need to mention the class levels. So class level is that your all of the classes name which you classified. So I simply classified them. Serially I put the name. I make a list, and then I simply move, suppose first of all water, then second is that urban, then third is that vegetation, then fourth is that bare land. Okay, then X level is not needed for this time. I simply remove this argument is not needed. I simply remove it. In this time you can see all of the things I stored in a variable. Suppose this variable name is that chart. Okay, now I simply print the chart. I simply print and then simply call the chart and click to the run. So now it's generating a chart in here. Okay, we can get the chart, but you can see I also add the something. Suppose in this time I want to add the chart as the same color with my map, feature. Suppose barren land I want to show as a yellow color bar column chart. Vegetation I want to show this bar column chart will be green color. Build up area I want to show the red color. Okay, then water I want to show as a blue color. So that's it also similar with my map. So in this time I also need to add some option. So I simply use the set option. This set option function I can simply add this. First of all I add the map title. You can see it's showing the band sum values by class. I want to add the band name, so I can simply put the suppose title. Okay, I can simply put the title, suppose LULC area. Okay, you can put any name as a title. Then I also add here the, you can see vertical axis and horizontal axis. So I simply use at the V axis. Here is the vertical axis. I put the vertical axis title as a, it represented the area. Unit is the hectare. I simply put here the hectare. SA Hector, and then I also added the horizontal axis, S axis, and I simply put the title as it's represented the class. Okay, you can put any title, no problem for this. And then I also need to add here, the another thing is the colors. Okay, I want to add the all of the bar colors. So first of all, water. I want to show this water bar column showing as a blue color. Okay, then I also want to show the urban, it's showing the bar column as a red color. Then I want to show the vegetation as a green color, and finally barren land as a yellow color. Okay, then click to the run. So now you can check, we can get the result according to our color. The same color we can also get in the chart. Okay, you can see we can get the water as a blue color, field of area we can get as a red color, vegetation green color, and vanilla. When I click here I can get the chart look like this. I can simply download it, all of the data in Excel file, and from this data we can easily get all of the area from this region, and also downloaded this PNG file format of this image. Okay, so in this time you can see I create the chart and I can easily get all of the area, but Google Earth Engine has some limitation for creating the chart. When it across the limit of 5000 element of pixel value, the chart is not apparent. Then we need to follow the another method. So this method is only applicable for the small region, such as Dhaka city, this type of sub-district, or any small region. We can apply this method and easily calculate the area by using the chart method. But when you want to work with the big region, such as full country boundary of Bangladesh, full country boundary of India, full country boundary of China, then we also need to follow the another method for calculating the area. So in this time, I also try to show you this part, how you can easily calculate the area as a big region. Suppose whole country boundary of Bangladesh, whole country boundary of India, how you can easily calculate the area. So let's go. I just simply open a new code editor and try to show you this process for the big region, how you can easily do this. So just I simply open my new code editor. Okay, so in this time, suppose I want to calculate the land use land cover classification map for the whole country boundary of Bangladesh. So first of all, I just simply import the shapefile of Bangladesh. I simply import this. And in the asset tab, I already imported my area. Okay, I just simply import this and put this name, suppose ROI. You can put any name. And then I simply show the layer in here. And put this name ROI. And also add here the map dot center object. And put here the ROI. Level 10 and click to the run. So now I can check, I can get my boundary. And for this boundary, I want to work with this land use land cover classification map and then try to calculate the area. So in this time, I am using the another data set. I want to use here the Moody's data set, Moody's land use land cover data set. And then I want to make this classification and then try to calculate all of the area from the Moody's data set. So I can simply go to the data set and click on the browse data catalog. And then find out this Moody's. You can see Moody's. I simply find out. And then I just simply find out my data set for the Moody's. So here I can easily find out. You can see the Moody's land use land cover data set. I can easily use in Google Earth Engine platform and classify this image. So you can see I want to use the data set Moody's land cover yearly global 500 meter resolution, this data set. So just I simply click on here. Here I can get all of the information about this data set. Basically, this data set is the annual or yearly data set we can get from here. And this data set is availability date between this time period. We can get the Earth Engine snippet in here. Also, you can see the resolution of this data set. This data set has some band. You can see LC type 1. So mainly this LC type 1, this band is that annual International Geosphere and Biosphere Program classification. Okay. Also, you can see LC type 2. This is the another classification. Also, LC type 3. This is the another classification. So in this time I use here the LC type 1, this band I want to use, and then classified. You can see for the LC type 1 we can get the some classes. LC type 1 I can get the some class. You can see label value 1, it represented the evergreen red leaf forest. Value 2, it represented the evergreen broadleaf forest. Value 3, and deciduous needleaf forest. Also you can see all of the class. You can see savanna, grassland, permanent wetland, cropland, urban build-up land, cropland, okay, natural vegetation mosaics, all of the things. Here I can get total 17 classes from 1 to 17. Okay, so in this time I use this data set and try to make this land use land cover classification map for the whole country boundary of Bangladesh, and then try to make calculated the area for the big region. Okay, so let's go. So first of all, I just simply copy this Earth Engine snippet from here, because this is the dataset ID of the Mortis land cover dataset. I just simply copy and then I simply paste here. Here I simply paste here. Okay, and then I simply put the variable name. Suppose I put the variable name such as suppose Mortis LULC. Okay, you can put any name, no problem, as a variable. So in this time you can see I simply put this name. Okay, so in this time before that I also try to discuss about the another thing is that vector area calculation. So vector area means that you can see this point line polygon. Suppose in this time you can see I can get the area of the whole country boundary of Bangladesh. So you want to calculate the area of the whole country boundary of Bangladesh. Okay, basically this is the shapefile, and shapefile is the vector format. Okay, vector data set. So how you can easily calculate the vector area calculation in Google Earth Engine platform. In this time I try to show you this part, and then I move to the classification using the Mortis land use land cover data set, and then also calculated the classified all of the area for the whole country boundary of Bangladesh. So let's go. Okay, so first of all, when you calculated the area for the vector area or vector data set, when you calculated the area, first of all I simply take a variable. Suppose I put the variable name, suppose state area. You can put any name, no problem. And then I simply call this. You can see this shapefile is stored in a variable. This variable name is the ROI. I simply use here the ROI, and then I simply use a function. It's called the area. So I simply use a function. It's called the area. I simply use a function. Sorry. First of all, I need to use the function geometry. So geometry, and then I need to use here the area. Okay. So first of all, I use here the geometry, and then I can put here the area. So mainly when you use the area, then we can get the result in meter square or square meter. So just I simply print this. I print this state area. Simply copy and paste here and click to the run. So now you can see it computing the area. We can get the result in square meter. Suppose I want to convert this in the square kilometer. Just I simply take the another variable. Suppose this variable name is that square kilometer area. You can put any name, no problem. I as a variable. And then I simply call this variable ee dot number. Then I simply call this. You can see this number is stored in a variable state area. I simply copy this and paste here, and then I just simply divide with 1 million. So I simply use here the divide with 1e6 scientific notation. I simply divide it. So in this time I just simply show the result. I simply use the print function, and then call this variable name is square kilometer area, and then click to the run. So now I can check. I can get the result. Okay, I can get the result in a square kilometer. 1,39,976.35 square kilometer. In this time, if you want to need only for the integer value, then you can simply use here the round function. So round function, when you click to the run, in this time I can get only for the integer value. In this here you can see I can get only for the integer value. Okay, so let's go. In this time, this is the process when you want to calculate the any vector data set. Suppose in this time this is the shapefile. Shapefile is a vector data set. You can easily calculate the vector. First of all, you can see it will be stored in a variable ROI. I simply call the ROI. Then I simply use here the geometry function and then use here the area function. When I print this, I can get the result in square meter unit. And when I simply divide with this value, then I can get the result in square kilometer result. So this is the process when you want to calculate the vector area. You can follow this. I hope you can easily do this for the calculating the any vector area in Google Earth Engine platform. Okay, so let's go. In this time, I just talk about that how you can easily use the dataset and try to make this land use land cover classification map using the MODIS dataset and then calculate the all of the area as a big region. So here I import the dataset EEMS collection and it's stored in a variable MODIS. So in this time, I just simply show the result. So just I simply call this, take a variable, suppose I simply put the variable suppose filtered. Okay. And then I simply call this MODIS LULC and paste here. I simply use a function filter date. In this time, you can see basically this data set we can get the between this time period 2001 to 2020 this time period. So I simply select the one specific time period. Suppose I want to need the land use land cover classification map for year of 2017, 1st January from 2017 December 31, this time period I want to need the data set, as well as I also need to select this specific band. What's the band I want to work? I want to work the LC type 1 band. So I simply copy the band name and paste here. Okay, so now you can see I want to get this result in here. So in this time, I just simply use another function. It's called the first. Okay, in this time, when I want to just print this filtered, simply copy and use here the size function and click to the run. You can see. Okay, so I need to use the first function before then click to the run and check it. Okay, I need to use here this sign LC type 1 because this is a string. When you want to print the string, you must be use here this quotation, then paste this. Okay, so now I put this. Okay, so now it's working. Here I can get only for the one. So you can see I can get only for the 1 year 2017, and this data set is the yearly. Okay, so that's why for the 1 year I can get only for the one image. Okay, so in this time I use this image and then try to make this land use land cover classification map, then work with this. So let's go. So for this I simply use the first image I take, and then I want to show the result. So for the result I simply just use here this map dot add layer and then call this filtered and click the run. So in this time I can get the result for the whole world land use land cover classification map. Then you can see it showing as a black color because I did not add any visualization in this time. Okay, so in this time I simply add the visualization. So they're already provided the visualization demo code in here. So just I simply copy the visualization code. You can see I simply copy and then simply paste here. Okay, after this I simply copy this variable name and paste after the object name and click to the run. So now this visualization will be set with my map visualization in here. Okay, so now you can see we can get this classified image for the whole world. But in this time I don't need for the whole world. I need only for the country boundary of Bangladesh. So just I simply clip with my shapefile, then I can get the result only for the country boundary of Bangladesh. Okay, so for this I just simply take the another variable. Suppose I simply take the variable, suppose put the variable name, suppose Bangladesh, LULC. You can put any name. Okay. Then I simply call this filtered, simply copy and paste here and use here the clip function. Clip with shapefile of Bangladesh. And Bangladesh shapefile is stored in a variable ROI. I simply use here the ROI. Okay. Then simply copy this variable name and paste here. In this time I want to get only for this Bangladesh area land use land cover map. You can see. You can say I can get this map only for the Bangladesh. So now if you want, you can easily export this map from here and you can easily work with this. You can easily work with this ArcMap software for creating this map. The same process as you can simply, and previous class I also try to show you this part how you can easily work with this ArcMap software for creating this map for your research paper as well as also your presentation work. So you can simply download this tip images, same function, export image to drive, and then you can easily work with the ArcMap software for make the map in for your research paper or your presentation work. So in this time I can get the classified map. Just I want to show you that how you can easily calculate the area. Okay. So mainly we can calculate the area in Google Earth Engine platform different way. So if you want, you can calculate the area only for the single class. Single class means that suppose from this map, I want to calculate it only for the urban area class, or I want to calculate it only for the water body class, or I want to calculate it only for the barren land. So single class. So how you can easily calculate a single class? I also try to show you this part. Suppose from this map, from this whole classification map, I want to calculate only for the urban map. Suppose I want to extract only for the urban area and then calculate the urban area. How much urban area is available for the Bangladesh year of 2017. I want to check it. So first of all, I need to create the single layer classification. Suppose I want to take a variable. Suppose I take the variable for the urban. I take the variable urban. Okay. In this time, I want to show only for the urban map of Bangladesh year of 2017. So for this, you can see Bangladesh LULC. This variable is showing for the all of the classes. Okay. So just I simply copy this, copy and paste here. Okay. In this time, I want to show only for the urban class or build up class. I use here the equal. Okay. Now question what I put in here. So I put the value which I gain from here. You can see this data set already added LC type 1 all of the class value. So you can find out the value for the urban. You can say urban and build up land. This value is the 13. Okay. For the cropland 14. I want to work with the urban and build up area. So I simply use here the 13. Okay. So this is the value for urban. So I simply paste here. Okay. So now this variable urban is stored only for the class of build up area. So for this, I just simply show the result. I simply use here the map dot add layer, and I want to show the urban. So I simply copy and paste here. I make a visualization. Mean it will be start from the 0 and max up to 1. I want to show the plated. So where there is the no urban, I want to show this color place as a gray color. I simply use the gray color. And where the urban is present, I want to show as a red color. Okay. And I also put the layer name. Suppose this layer name is the urban and click to the run. So now you can see I can get the another layer in here only for the urban. You can see I can get another layer is only for the urban. And then I can simply work with this urban and you can see. So now where I can get this urban area or build up area, it's showing as a red color. You can see red color. And where there is the no urban or build up area, it's showing as a gray color. So now it's showing the urban map of Bangladesh year of 2017. There you can see. If you want to export the same process, you can easily export and work with the ArcMap software for making the urban map. Okay, you can say I can get this all of the urban pieces. Suppose you want to need only for the cropland, you want to identify only for the cropland year of 2017. Just you can simply put here the cropland value. You can see croplands at least 60 cultivated cropland. This value is the 12. So just I simply copy 12 and just use here the 12. I want to show the cropland as they suppose yellow color. Okay, yellow color. You can use any color, no problem. And then click to the run. So now it will be represented only for the cropland of Bangladesh. So now you can see it showing only for the cropland of Bangladesh in here. Suppose you want to show only for the water body, just you can simply find out the water body. Suppose you can see the permanent wetland, also you can see grassland, savanna, also you can see water bodies at least 61. So I can simply the 17 water bodies I want to show. So I simply copy and then simply change the value in here and click to the run. So now it's showing. I want to show, suppose I want to show the water body as a blue color. Okay, so I simply use the blue color. Then it's better. Then click to the run. Okay, so now you can see I can get only for the water body in water body map of Bangladesh in here. Okay, so now I can easily export this map as a TIFF format and work with the ArcMap software for making the water body map of Bangladesh. Okay, so in this time you can see this is the process for how you can easily create the single class map. It can be only for the urban map, only for the water body map, only for the build up area map, only for the cropland map. It also possible when you want to make the supervised classification. Suppose in this time, from this map, I want to extract only for the only for the build up area or urban area. The red color identify the urban area. Okay, same process I can apply in here. Okay, so I can simply show you that process also in here. So I can simply take a variable. Suppose put the variable name is the urban. Okay, and then this image, this classified image is stored in a variable. You need to find out the variable name. This variable name is that you can see classified. Classified. I simply copy and then simply paste here. Okay. In this time, from this classified images, I want to need only for the urban map or urban area or urban feature. I just simply find out and go to the urban. You can see I click to here. I can get the urban value is the 1. Okay. So just I simply use here the equal sign and set the value for the 1. Okay. So now I want to show the result. So I simply use here the map dot add layer and then I simply call this urban and then I simply make the visualization such as mean. It will be start from the 0 and max up to 1. Okay, and then I simply use the plated for the color. I want to show here there is the no urban. It's showing as a suppose gray color, or you can use any color, no problem. And show where is the urban. I want to show as a red color and click to the run. So now you can see it showing only for the urban map. From this classified image, I can get only for the urban map in here. And very less urban area we can get from here because there's a very less urban feature in here. You can see we can get only for the urban feature. We can get some urban region in here from this place. Also, we can get the some urban feature. So very less. Suppose I want to extract only for the vegetation. So just you can check out the vegetation value. You can check the vegetation value is the 2. Just you can simply put here the equal to 2. This is the value of the vegetation and change the color. I want to show the vegetation as a green color and click to the run. So now you can see it's showing all of the vegetation area of this region. Okay, you can see we can get the lot of vegetation area in here. Okay, or water body, same process. You can only for the water body, simply click to here. Water body value is the 0. You can simply set the value as a 0 and show the color for the water body. I simply show the color as a blue. You can use any color and then click to the run. Now I can get this only for the water body, struck only for the water body. In here you can say I can get the water body. So now if you want to, suppose I want to calculate that how much water body is available in here. I want to calculate it only for the water body. So how much water body are available in this place. So in this time I try to show you this part how you can easily calculate this. So for this I simply take a variable. Suppose this variable name, you can use any variable name. I can simply put the variable name in the suppose area image. Okay. After this, I just simply call this variable name urban. Okay. You can use any variable name. You can say I put the variable name urban, but I want to show the water. There is no problem. Variable name can be anything. If you want, you can use the water. There is no problem also. I simply use the water and also put here the water. There is no problem. Okay. In this time, I simply call this water and paste here. Okay. And then I simply use a function. I can simply multiply with this function. This function is that image.pixel area. This function I simply multiply with this. Okay. So I simply use that the multiply with this function is that image.pixel area. Okay. So now I can check. I want to calculate the area for only for the water body. Okay. And when I want to use this image.pixel area, I get the result in square meter. This unit I get the result in square meter. Suppose I want to need the result for the other unit, then I can simply modify this unit and I can get the result. So now you can check here. I just simply show you this result. So I simply take a variable and give the variable name such as area. You can use any variable name. Okay. Then I simply call this area image. I simply copy and paste here. And then I simply use here the reduce region. Okay. So now I can check. I get all of the argument in here. I simply make a dictionary in here. I simply put the dictionary and also put the another dictionary, curly bracket start and int. I put all of the argument one by one. First of all, reducer. So reducer is a statistical function. In this time, I want to calculate the total area, all of the pixel of water in total area. So just I simply use here this dot reducer dot sum. Okay, I want to get the total area. Then geometry is a shapefile variable name. This is the ROI. I can check it what is the shapefile variable name. Okay, so it's a lowercase ROI. Okay, so just I simply use here the lowercase ROI. Then scale is the resolution of your satellite images. This 30-meter resolution. Okay, then other thing, I simply remove all of the things. It's not needed for this time. I simply remove. Okay, so now I can check. I want to print this, so I simply print and then simply copy the variable name area and paste here and click to the run. So now I can check. It will be printing our result. How much area I can get. You can say I can get the total area. And this unit is showing as a square meter. Suppose you want to convert the unit in a square kilometer, we can easily do it. So for this, in this time, I just simply take the variable. Suppose I can simply put this variable name is that water. Suppose a square kilometer. You can put any variable name. Then you can see this is a number. Okay. This number is stored in a variable. Okay. This variable name is that area. Okay. So I simply use here this dot number. Okay. And then I simply call this variable name is the area. Simply copy and paste here. And this number I want to get from the classification. Okay. So that's why I simply use here the get function and use here this classification. classification. Okay, I get this number, and this number I can get for the classification. And finally, I simply use the divide function, divide with 1 million or 1e6 or 1 into 10, 10 to the power 6. I simply divide it, and now I simply print this result. I simply print this result, water, and simply paste here and click to the run. So now I can check, I can get the result. In here you can see. Okay, so now I can get the result in square kilometer. I can get the total 8 square kilometer region of water body for this region. The same process you can also calculate the other single class also. Okay, so in the time, suppose as a big region, suppose I want to work with this big region, I want to calculate the area. Same code I can use. So for the big region, for the single class calculation, whole area of water body or urban body, anything single class, I can simply copy the same code from here. So just I simply copy the same code from here. I can simply copy the same code from here. Simply copy and then paste here. Okay. In this time, I simply show the result such as I want to calculate it only for the suppose urban area. I want to calculate it. So urban area is that you can see this is the urban and below is the 13. So just I simply put here this 13, and then I simply show the urban area as a red color. Okay. Then when I click to the run, I just simply commenting, and first of all showing this image. You can see I can get all of the urban map in here. Then I calculated the how much urban area is available for the whole country boundary of Bangladesh year of 2017. I want to observe it and calculate the region. Okay. So now I can check, I can get the urban area. In this time, I just calculate only for the urban area. The same code I can use. So first of all, you can say I take a variable area image. Okay, I simply call this urban. I simply copy the variable name and paste here. Okay, multiply with my function e.image.pixel area. Then I just simply use here the same function I can also use in here. So I can take the variable area, then call the area image. So all of the things will be same. So now you can see here in this time, this resolution I can use here the modis resolution is that 500 meter. So just I simply change the modis, it will be 5000 meter. Okay, then I simply print this. So I simply print this, then I can get the result urban map information. You can see. So now I can see here I can get the result. Okay, it's showing the ROI is not defined. Okay, so ROI is that our variable shapefile variable name, and shapefile is that lowercase ROI. I simply copy lowercase ROI and use here the lowercase ROI. Okay, and then click to the run again. So now it's computing the area. And when I click here, I can get the result. You can see I can get the result in square meter. So I simply convert the result in the square kilometer. So just I simply write the code. I take the variable, suppose urban square kilometer. You can use any name, no problem. Urban square kilometer. Then I want to get the area. In this time, I can get the area. From this band. This band is that LC type 1. Okay, I simply copy and then paste here the LC type 1 and paste here. Okay, then divide this. I simply copy the variable name urban square kilometer. Simply copy and paste here and click to the run. So now it also convert the unit as a square kilometer also. Okay, we can get that 1068 square kilometer region. If you want to need the only for the integer value, you can simply put here the round function and click the run. Okay, we can get only for the integer value because I use here the round function. So now, anyone any question about the single layer calculation or single map showing? Any question or any doubt? Anyone? Any question? For creating the chart and also calculated the single area, showing the single layer map. Okay, so if there is no question, then I also continue. And then face any problem for any time for regarding this calculation, then you also just contact with our WhatsApp group. I hope you can get the solution. And I also send I will send you all of the practice code as well as also send you all of the recorded video class, so that I hope you can easily understand all of the things. Okay, so in this time, suppose I will not work only for the one class. So here you can see there are a lot of class: water body, built up area, vegetation, different types of vegetation. It will be available in this classification. So I calculated all of the classes area at the same time. At the same time, I calculated all of the class. Okay. So when you calculated all of the class at the same time, then we also need to work with the group function. So I want to create the group. And in this group, I just simply calculated all of the things one by one. So let's go. So first of all, I simply take a variable. Suppose in this time I try to show you the group. So in this time, all of the class I calculated at the same time. Okay. And this is the process for calculating only for the single class map. Suppose only for the urban, only for the water, only for the build up area, only for the vegetation, how we can easily handle. I also show you that part. In this time, I try to show you that suppose all of the class at the same time. In this image, this is our classified image. In this classified image, I want to calculate all of the class at the same time. Okay. So let's go. So for this, I simply take a variable. Suppose this variable name is that, you can use any variable name. I simply put the variable name is that area image. Okay. And then I just simply call this function. This function is that e dot image dot pixel area. Okay. In this time, in pixel area, with the function, this is my function. This function I also add with my classified image. Okay. So I simply use a function add bands. Add bands. And it add with my classified image. And classified image is stored in a variable. What is the variable? You can see. This variable name is the Bangladesh LULC. I simply copy and paste here. Okay. So now I just use here this Bangladesh, and then I can see I simply try to take the another variable. Suppose this variable name is the area or areas. You can use any variable name. Then I simply call the area image and paste here. I simply use a function reduce region. Same function I use. And then I can get all of the argument. You can see reducer geometry. I make a dictionary in here. I simply put a curly bracket start as well as also curly bracket int. Okay. Then put all of the argument one by one. Then I just click to the